Making any fraction into a decimal is an essential math skill from here on forward in middle school and into high school. This is an example here of how the fraction 1/4 or 1 divided by 4, or even if you recognize it as 1/4, can be made into the decimal 0.25, which looks like 25 cents or a quarter, by taking the fraction and making it into a division problem. So this worksheet behind here is something that you're actually going to be given. I'm going to show you some patterns, and then you're going to need to remember what you see and complete and finish those patterns. There are lots of real-life reasons why we need to be able to make fractions into decimals, and eventually you'll have to go backwards from decimals into fractions. You'll have that skill. You'll see the relationship between fractions, decimals, and percents, but for today, just know that you need to be able to do this. It's an important math skill. So on this sheet right here, there are going to be several examples, and your sheet will actually have more information than this blank one shows, but here we go. If I had the fraction 3/4, for example, right here, or I had the fraction 7/8 right here like this, then this is what would happen. The first thing I'm going to do is I'm going to ask you to imagine that imagine the division bracket sitting over the top of the fractions line. So you would imagine something like this. Here's the curved part of it, and here's the straight part. Here's the curved part of it, and here's the straight part. You're imagining a division bracket over the top of it. The second step says tip the fraction over to the right, so rotate it to the right. The numerator becomes the dividend, and the denominator becomes the divisor. Obviously a lot of math terms there, but what we're doing is we're taking this and we're going to turn it sideways. So that means that the 4 would be on the outside, and the 3 would be on the inside. The 8 would be on the outside, and the 7 would be on the inside. The next step says put a decimal to the right of the dividend and add at least 1 0. So I'll zoom in because I want to make sure this is clearly seen. I would start with whatever my step was above, I'm going to complete it below. So I have a 4 and a 3, I have the 8, and I have the 7. I'm going to put 1 decimal to the right of that digit in the dividend, and then a 0. I may need to put more zeros, but at least put 1 in both cases like that. That allows me to do division, because originally I wouldn't have been able to take 4 from the 3, but now I certainly can take 4 from what looks kind of like 30. I couldn't have taken 8 from 7, but I certainly could take 8 from 70. The next phrase here is this one, is if there's a decimal in the house, raise the roof. That means this. If I have 3.0 being divided by 4, the next step is to put a decimal straight up from it. I can't put it off to the other side, I need to go straight up from it. So over here, I have 8, 7.0, and I'm going to go straight up from that and put it right here. Okay, the next step is to use the division standard algorithm, and you're going to add more zeros as needed to continue the division. So again, I'm going to copy whatever I have above, like that, and I'm going to work my next step. Can I subtract 4 from 30? Yeah, I can do it 7 times at least to begin and to start the problem, and that would be 28. 7 times 4 is 28. And I'd have 2 left there. But because I have the decimal in place, I can now do this. I can add another 0, and I can even extend this line if it were necessary, and continue until the division ends, basically. So I drop this 0 down, and I make that 20. I can subtract 4 from 20 5 times, and I get 0 there. And then that even makes sense. I started with the fraction 3/4, or 3/4, and 3/4 would be 75 cents. 3 divided by 4 is 0.75. That means if I had 75 cents 4 times, that'd be $3, is another way of looking at it. So over here, same idea. 8 from 70, well, I could take it 8 times, because 8 times 8 is 64. Sometimes students think it's 9 times, but 8 times 9 would be 72, and I can't subtract 72 from 71 in this algorithm. So here we go, 70 minus 64, I get a 6 in this place, but now I need to add another 0. So let's stick another 0 on there, and I drop that down, and I get 60. 8 goes into 67 times, that's a 56, and then I end up with a 4. I can put another 0 on, and I can extend my line, try to keep everything nice and straight and neat. I have 40, and 8 goes into 40, or 8 can be subtracted from 40, I should say, 5 times. and there it is. So the answer up here is 0.875. So the last one down here, I just need to recopy this answer. I just need to share it like that. 3 divided by 4 is 0.75. 7 divided by 8 is 0.875, and I don't have to worry about my decimals matching up or that sort of thing. However, there's an interesting thing that does sometimes happen. If I had the fraction 1/3 like this, and I were to do this division, let me show that real quick here, and I were to take 3 from 10, I get 3, 9, and if you see this real quick here, what's going to happen is over and over again, I'm going to have 10 minus 9, 10 minus 9, 10 minus 9, 10 minus 9, and I'm just going to keep writing 3's like this. When that happens, I have a special symbol. It's a bar that is placed over the repeating digit. So the answer to 1/3 here is 0.3